Okay, so today we're going to work on permutations. Okay, the thing you need to remember here with permutations is that order matters, or you can also say roles. Okay, so not just groups, order matters within this topic. Okay, so to look at this, let's take a look at this question here. And we've done this already with factorials. Factorials is a window of permutations. Okay, so if I have five friends who are getting together for a picture, but only three can be in a picture, how many three picture arrangements can there be? So we have three people here. So we'd have five options for the first one, four for the second one, three for the next one. Now, if I were to write that as a permutation, it'd be 5 factorial over 2 factorial. Now, working all this through is kind of, it takes a little bit of time. So we can use it as a permutation. And the way permutation works, this permutation would be 5p3. Okay? So the 5 is all options. The 3 is the number you want. Okay? So let's make sure here, just to prove it here. So if I did 5 factorial divided by 3 factorial, that will give me 20. Now you have a permutation button here. It's on my screen right here is NPR. So I'm going to go 5, second function, there, and press 3. Oh, what happened there? 5 factorial divided by 2 factorial, sorry. 5 factorial divided by 2 factorial is 60, and 5p3 is also 60. Okay? But the thing you have to remember there is when we do this, so it's all options, and this is the number you want, how many I want. Okay? So for this one here, if I had 10 people on a basketball team, how many orders of 5 can be introduced? If I did it like this, like we did factorials, we have 10 options, then 9 options, 8, 7, 6. If we want to look at it as a permutation, I have 10 players, and I want to introduce 5 of them. So it'll be 10. Can I get that 0? P5. So I'd have 30,240. And that's the exact same as going 10 times 9 times 8 times 7 times 6. Exact same number, but a lot easier to write this. Okay, so we're just going to go through a whole bunch of these. Okay, there's 43 cars racing in Daytona 500. How many ways can the cars finish first, second, and third? So first, second, third tells me order matters. So all my options is going first, and then how many I need. So there's 43 cars in the race, and I need the top 3. So 43 P3 is going to give me 74,046. Now I'll let you do this one. There's 12 people in the race. How many different orders can we have of first, second, and third? I'll let you pause it here, do it up. So we have all options. We have 12 total people, and we want 3. So 12P3 is 1,320. Okay. Now we're going to get into the more difficult ones here. Let's look at number 12 here. Victoria has textbooks for 7 courses she will study this year. How many ways can she arrange her textbooks? I don't like that one. That one, I'll still do it here. 7 textbooks. 3, 4, 5, 6, 7. See, this is how I do this one. French and Germany have to be beside each other. So I do my box method here. And I said beside each other, but not having to be one next to the, like one goes first. Then I would count up 2, 3, 4, 5, 6. So I would answer 6 factorial times 2 factorial. Okay, so here's one with roles. 10 people are attempting to get on student council. There are 4 positions. How many different student councils could we have? Once you figure it out here and pause it. Now, it'd be 10 P4. That would give us our total number of different student councils that we could have. Okay, so now you and your 2 friends must be on student council. So I'm going to have 2 of these now. Okay, this one here is going to be the 3 friends, you plus the other ones. So you must be on student council. So there's 3 friends, and all 3 of you are going to be on student council. So all options is 3. How many I need is 3. Then we're going to have 7 people left for 1 role. So that's going to be your answer there. It's going to be 3P3 times 7P1. So now we have 42 possible student councils. Now this one, only one of the 3 friends make it on student council. Only one of 3. So this one's going to be for you and your friends. This is going to be for everyone else. But I only want 1. So there's 3 friends. How many do I want? I want 1. Okay. Then there's 7 people left over, and they're going to fill the other 3 spots on student council. This is 7 because I took out the friends. Like there's 10 people originally, minus the 3. So I want, this group is not any of your friends. So 3P1 times 7P3. That gives me 630. Now a little bit different here, a minimum of 1 friend. A minimum of 1 friend. So a minimum of 1 friend is going to be, I'm going to put 1 friend on it right now. So one of the friends is on it, and that's including you. Then I can have more, so there's 9 people left this time for the 3 spots, because I can have one of the other 2 friends be in there. Because if we pick a friend, that's perfect because we have a minimum. Then exactly 2 of 3 make student council. So exactly 2 of the 3 student count, 3 of the friends. Okay. So this is my 3 friends. I want exactly 2 to make it, and then I'm going to, other 7 people, they're going to fill the other 2 roles. So if I was doing my calculator, it'd be 3P2 times 7P2. 252. Let's keep going. Let's do a whole bunch here. I have to erase these ones. Look away for a second. I'm going to go back up here. So these are all the different ways that you can express a permutation. So let's say we're doing like 12p6. We could write 12p6, or sometimes you'll see it written 12 comma 6, or you'll see it as 12 factorial divided by 12 minus 6 factorial, which would equal 12 factorial over 6 factorial, which makes sense along those lines. Okay, so all those are equal, right? So let's go down here. Oops. So 12 people on a volleyball game. How many 6-person arrangements can be made? Arrangements say order. So I'll let you answer it here real quick. We have 12 people, and I want 6 of them. So we 12p6. Now, let's say one of the players is Ashley. Let's say Ashley is not in one of the arrangements. So Ashley can't be in the arrangement to start. What would that be? If I took Ashley out and she was no longer available, how many arrangements would there be? Well, if I take Ashley out, there's going to be 11 people available, and I still need 6. Which will equal 3, 3, 2, comma 6, 4, 0. Right? So 8 teams in a league. How many ways could the top 4 orders be finished? So 8 teams in a league. How many ways could the top 4 finish? So 8 total teams, and I'm interested in ordering 4 of them. That's what that would look like. All right. That's all my questions. Let's see what else we got here. Don't like those ones. Okay, I think we're good along those lines. So the big thing here is that permutations have order. Okay, they have order. Order matters, or roles. And when you do a permutation, all options go here. And here is the number you want. And go from there. Okay? Any questions, feel free to email me, and have a great day.